Hello everyone, it's February 23rd, very late. Um, what a day. Most of the day spent on implementing the fast IC algorithm, the independent component analysis, which is just black magic. It was very, very eye-opening to learn about this and also to implement it. The implementation took a while because I guess I just don't fully understand when I was learning about it in the class. I didn't fully understand how the data will be passed in, like what the data shape should be like. Without knowing the data shape, it's actually really hard for me to really reason what this whole thing should look like. And it took a lot of time to try and error, and also reading into scikit-learn's ICA. Scikit-learn has the implementation of fast ICA, so I use that to to see how the input shape should be, and also go to their GitHub page to look at the source code, how it was implemented. So a lot of try and error, and eventually, and also some stupid mistakes. Like two main mistakes. One is the singular value need to be raised to the power of minus 0.5, and I got a mistake in my notes. When I was taking the notes, I wrote it down as zero point 0.5, and didn't realize until I actually read the paper. Understanding of linear algebra was lacking, so I was supposed to do the widening. Yeah, both mistakes are related to the widening process. I was supposed to do widening, right? And the widening, you need to get the um, eigenvalues and eigenvectors of the input data, right? For the input data, and of course, I I don't like to use the PCA anymore because PCA basically just SVD. So I was trying to use SVD, but the target of SVD should be the covariance matrix of the centralized input data. But I accidentally, erroneously, did SVD on X transpose, right? So it's X transpose is not the covariance matrix. The expected X transpose is the covariance matrix. This is like this is very different, the two things, and I got the two things confused. And since I got confused, I just never produce the right result until I check. You whiten the data should have covariance matrix or covariance as a one, right? So they should be independent. But mine is not independent. Then I kind of realized, that was the issue. I was supposed to do expected, right? Expected value of the of x transpose. But eventually, what I did was just covariance, because NumPy has covariance cov, the cov function. So I just called numpy.cov on my x, and that's it. That's it. I mean, nothing too fancy. Yeah. So, but it took a long time. So after that, I had to organize my notes uh, on Fourier transform and Fourier analysis. My God, that was just a bomb 2 days ago. No, yes, yesterday. That was a bomb yesterday. Like a fast track, 1 hour and 20 minutes of fast track into Fourier transform. Wasn't able to follow everything that professor was talking, and I missed notes. Today I have to rewatch the lecture and reorganize the notes. And finally, I think everything. I won't say everything clicked. It's not clicking yet. It's just I do follow the logic, but this is a completely new area for me. I remember I wanted to learn Fourier transform back in undergrads because there are some equipment, MRI. There's some fMRI equipment in my lab that like nobody wants to touch it because you have to learn Fourier transform in order to analyze the data and understand how it works. And I was like, yeah, I can learn that. Yeah, but never did. Honestly, I think if I was there, I don't think I can. I'm able to learn. This requires teacher. This requires a good teacher to help you digest because as I see online, all the Fourier transform, it's just throwing you the equations without any proof, without any step by step understanding how it arrives there. I guess I mean when I was in China, I don't have access to let's say three blue, one brown, right? I know he has a series of Fourier transforms that I can follow. So I didn't really have very good material back then. But right now, like yeah, I mean here it's definitely the materials are out there. I just need to take some time and really calm down and follow through all the math, like what I did with the notes from the teacher. I follow through all the math just to prove everything. And well, I won't be able to like say, you prove it now and you can prove it again very fast. That's not possible. If you need to calculate, you need to calculate, and then there's a lot of integral. Right? I don't know. I mean, I can do it, but I don't want to. So I just check online for the integrals. But overall, it's quite an experience, and the teacher is gonna dig even deeper. Like tomorrow, I think tomorrow is a fast Fourier transform, but it's all good. Like I think I mentioned a while back, the only time to learn something hard is right now. Like I don't really think when I start working, when life really picks up, I will have enough time or efforts into this. This is the only time. All right, that's it for my babbling. Wow, I babble so much, it's almost midnight. All right, let's get into this. Just solve this, and then we call it a day. I don't have time. I don't have the efforts. I'm very tired right now. All right, so that was okay. Given a head, return the list after sorting in ascending order. Can you sort the linked list in O n log n time and O1 memory? Constant space. Constant space. Okay, that is the question. How do you sort in constant space? Well, so we just need to swap it, right? We need to swap. I was thinking about what are the O1 log n sorting? Quick sort, right? We can pick this one as the pivot, and then oh, how? How do you do quick sort on this? Oh, we can divide and conquer this, but does that count as O1 extra space? Wait, how do you do quick sort? We pick one, right? And then we sort, and then we sort this, and we sort the front or sort the back. Does that count as O1 memory? I guess recurve doesn't count. Yeah, let's just try solving it in a quick sort. So I pick this as the pivot. Everything larger than this need to go to the end. But I need 2 pointers. How do I have 2 pointers? Can I have a pointer on here? I can have a pointer here. Well, I mean, for this one, they're all smaller, so we don't move, right? And at the end, we just, swap the value. Okay, we can swap the value. We walk all the way down. Then we swap this to swap the value. And then we can do, say, we'll sort this part. So 3, 2, 1. We sort 3, 2, 1. And then we swap 3. We 1, 2, and we finish swap. How do we? That requires 2 pointers. It does require 2 pointers. I mean, we can merge sort, right? We just divide it in half. We can divide in half. One goes fast, one goes slow. So whenever I reach, that's the middle point. And we can just, because we go 1, 2, and 1, 2. So that has the middle point. And I just cut a middle point, right? So if you want minus this and 4, 0. And I will sort these two. Once I sort, then I merge, right? I merge the two. I'll have a dummy, and he will go, yeah, blah blah blah. So we'll create a new one. I return the root. Yeah, let's do merge sort. I think this is for merge sort. Basically, this is just a question of, can you write merge sort? I had a merge sort before. I think I can write merge sort. All right, so merge sort, right? And if not head, return none. If not head or not head on next, return head. Right? Else we'll at least have 2. And then we're gonna say slow fast equals head and head. Right? And while fast and fast on next. Slow equals slowed on next. Fast equals fast on next on next. Okay. So once we're done, we'll have the slow, right? Slow, and we need to break. So we're gonna call left, sorted left, like sorted left equals self dot sort this head, and I need to terminate it, right? So let's say is sorted. Yeah, let's do sorted right first, right? Sorted right equals self dot sort list slow. Yeah, we can actually say slow. What if it's even? So yeah, slow. Yeah, slow to the end, and after that, let's say, oh, cannot use if I use slow. Shoot, if I use slow and this one doesn't end. Okay, I want to end at this position. So I add one. So one, this one go 1, 2, go 2 times. So 1, 2, so ending here. Okay, that's fine. How about this one? 1, 2, it's also 2. So we go 1 and 2, so here, so I cut here. Which is fine, yeah, okay, let's do this. Dummy equals list node, next equals a head. And then slow will be start with dummy, and then right will be slow down next, right? So 1, 2, the slow down next, this is this. And after that, we can do slow down next equals none, right? We do slow down next equals none, and then do head, right? So after these two, we have sorted left, sorted right, and then we're gonna merge the two, right? And then merge. We should have the dummy. And we're gonna say node equals dummy, right? And I'll have sorted left and sorted right, and we just say a while sorted left and sorted right. Okay. While sorted left and sorted right. When I say if sorted left dot val is smaller equal to sorted right dot val, then node dot next equals sorted left. Node dot next equals sorted left. Else node dot next equals sorted right, and sorted left equals sorted left dot next. Here sorted right equals sorted right dot next. Okay. So node dot next pointing to this, and this one goes to the next one. And node equals node on next. Right, so we move down. And once we break out and say if sorted left, then node on next equals sorted left. It means sorted left we have something remaining. And hold on, let me see. So the next one, so if I say, then it will point into none, right? One of them is none. Otherwise, yeah, that's how it ends. It pointed to something, to none, and I come out. And we just say if equals sorted left, aleph sorted right, then node on next equals sorted right. If nothing, then we don't do anything. And return dummy on next. Okay, so that's my merge sort solution. Yep, I think it's correct. Yep, 601. I'm surprised since they're right in the first try. course, I want to take a look at this. Take a look at the solution. 48. Merge sort. And log in. 01 is login time. 01 space if not counting recursion. Okay, what's the time? I forgot the time. 410. 410. Seconds away. 73% ranking. Well, it's actually not too shabby, right? It's not too shabby. Not too shabby. Alright, so first take a look at, yeah, memory usage is slow. It's not slow, it's not much. Let's see. Merge sort. Bottom up. What? Count length. I have to count length every single time. Ah, this one's actually better. Oh, I like this one. Yep. You can say no.next equals sorted left if else sorted right. So one line. Yeah, look at this. It's the same. Then oh, doesn't matter. I don't like this. Is recursion is easier, much easier to handle. What's the official? Merge sort. Top down merge sort. Ah, back then I had time. I was investing in the top down and bottom up. Yeah, I don't have the brain power. Heady line. Yeah, that's a very, very long solution. For what? Like, why would you want to do a bottom up? It's not supposed to be, right? But I mean, if you think about it, it can be done. You break it down. But why? Why? You're just asking. Yeah. LFU. So not LRU. LR is last uh, recently used. What's LFU? No, I'm not doing it. What's LFU? Cache. Least frequently used. I don't think I've done this before. That'll be fun. Alright, so yeah, that's that. Well, I'm gonna go to sleep and I'll see you guys tomorrow. Adios.